this, and whenever you see this, you probably already think of two systems of equation, and then you're just solving them. So it's saying it has infinite many solutions. That means it must have the same. It's basically the same line, right? They draw the same line twice. That's the only way for a linear line to have infinite many solutions. This is a linear line, like you can tell. These are two linear lines. And then since it's the same line, it should have same slope and same y-intercept, right? So what does that mean? So remember how it usually looks like this, where there's like two lines, and then it has no solution or something. So then you pair these two and these two. But if they are the same line, you can pair these three for standard form, right? This goes with this goes with this goes with this, and they're all proportional, right? Because it can be scaled up infinitely. Well, in this case, since you can't even see the y, that means you have y equals mx plus b, and then y equals mx plus b, right? These are the two lines, and they basically just set these two lines together. So what does that mean? That means that m must be equal to the term here, and b must be equal to the term here. So that's what we're going to try to do here. So the first thing we're going to do is make everything simpler. So I'm going to multiply by 4 on all sides, or cancel everything out. Sorry. So cancel everything out for 12x and 28. So it would be something like 3x plus 7, and then minus 13 and everything's the same. And then multiply by 13, right, on both sides, and you'll get something like this, right? And then you simplify it, it'll look something like this, right? Once you get to this part, usually what you did was you measured. First of all, I think you might have messed up in one of the calculations here. Don't worry, I did it as well when I first tried. But this has to be the same. So negative 104 must equal to 91 minus s, right? And 113 rx must equal to 39 rx, right? We made that clear just now, right? Because mx plus b has to be equal to mx plus b. So we can create a system of equations from here. 39, let's start with this first, because this one, you can cancel out the x. As you can see, the x you can cancel out. Like the terms will be the same. So you don't even need to include the x. I just included, but 39 equals 13r, and you can find r. Because this one, why are we doing this first instead of what you did was immediately jump to this, was because you notice how this one has two variables, and you can't solve something with two variables with one equation. So you need to find out one of the variables first before you move on. How can you do that? You luckily have this. So yeah, so that's what we're gonna do. Sorry. So that's what we're gonna do. So let's solve the one with one equation. So yeah, with one variable first. So you solve this and you get r equals 3. Now you can plug it back into the other one, which is 91 minus s times negative 104 times r, and then you solve for s should get 403. So that's how you get this on correct. Alright, so let's move on to the next one. Next question. So for this question, I just kind of understand. The moment I see this, I just understand what it means, right? So it has this equation, right? And then r of s over is k. I always think of vertex form. I'll immediately think of vertex form, and in this case it will not be vertex form because it doesn't ask for your vertex. It just asks for real solutions. So this is a distraction, so I'll just eliminate this part, because whenever there's h and k I think of vertex, but I'm gonna remove this part which says k. So r must be greater than 0. So if r is greater than 0, it must be pointing up, right? And s must be less than 0. So whenever it says r over s must be greater than k, immediately you think of, oh, r of s must be a negative number. Because one's bigger than 0, one's smaller than 0. So one over the other, it must be a negative number. So you can rewrite this into saying r over s must be negative as well. Must be less than 0. Right? You can also write that. Right? Because it can't be 0. R and s can't be 0. So because it can't be 0, it must be smaller than 0, once you put it together. One's positive, one's negative, right? So let's move on. So what we did was we used determinant form. Whenever you think of how many solutions there are, right, you think of determinant form, which is b squared minus 4ac, right? So we have this instead is because it must be greater than 0 because of the reason that you want two solutions, right? So let's see. Let's continue. Basically, I plugged in. I had this equation. I basically divided by everything by 6, and you'll get something like this. And r equals a, right? Negative 6s equals b, and c is also r. So b squared minus 4ac, I'll plug it back in. So in this case, I'll plug b squared, which is r, which is negative 6s squared, 36s, right? And minus 4, a is r, c is r, so minus 4 squared, or 4r squared, right? And then you notice 36 and 4, you can cancel it out, make your life easier. So I canceled it out into this, right? And once you get to here, what I want to do is, I want to look at my clues. So how do I move up from here? The only clue I have is r over s. So I would assume I need to move r to have an r over s, an equation where there's r over s. How can I do that? I move r to the other side, right? And make this to the other side, which I did here, and then I divide by s. Then if I do that, I'll have r over s, or r over s squared, something like this, right? So I do that because it gives me a clue, because I have no idea how to move forward. I have to go back to the question and see what I need with the r and s. In this case, it gives you r over s. So I restated the same thing twice, just to be clear. Then you have r over s squared, right? I'm just simplifying things. And r over s squared, whenever you move this, you have to be careful that the sign changes or not change. In this case, you're only dividing by s squared, so s must be negative. We stated that earlier. So, but negative times negative is positive, so the sign actually doesn't change. But you gotta be careful. What if the sign changes? Then the answer will be totally different. So then you have r over s squared equals it must be greater than 9. And what you basically do is you make an equation, right, where you square root both sides. Whenever you square root both sides and you have inequality, it could be a plus or negative sign, and they will have plus and minus, right? Plus and minus. So you have these two, right? And in order to draw that on a graph, it will look like this. It will look like 3, 0, negative 3. It'll be from here to here, right? Because r over s can't be either this or this, because it has to be between this little phrase. This is just inequality. When it comes to inequality, when square roots, it's just a rule, basically. So that makes logical sense. So that r and s could be a range of numbers. Yes, though you'll have answers that look like this, but yeah, that's when negative signs get involved. So in this case, there's one positive sign. So one positive sign would be the same. So r over s positive 3, and then the negative 3 sign would be different, right? Equals 3, like this. And then when you negative 3. So when it becomes like this, you can basically rewrite this into negative 3. Rewrite this equals negative 3 r over s over 3, right? Like this. So negative 3 r over s, and that's what I did, right? So here, but what I needed to be careful of was r. It says r is positive, s is a negative number, and we made sure that r over s, or k, or this k, value of k, must be what? Must be less than 0, right? So it must be a negative number, right? In this case, we know it's a negative number. So out of these two, because the restriction has to be a negative number, it must be r and s must be it's closer to this, right? Because it can't be a positive number. And then out of this, the smallest number is negative 3. So my question for you is, why do we need to do this part where there's a negative number? Why do I have to check r over s as a negative number or a positive number and all that? Why do I have to do this step, right? The reason why you gotta do this step is, I'll give you a minute to think about it, and I'll reveal the answer. You can pause right here, and then try your best to solve it. Alright, time's up. Yeah, the reason we want to make sure is that in this case it's a negative number, right? But what if in this case it looks like this, right? Something like this, or like this, sorry. Then in this case r must be a positive number, s must be a positive number. That means the lowest number you can go for is actually 0, because you have a range of -3 to 3, and the lowest number from that's positive is 0, right? So that's how you do this question, or like this, or something like this. The reason why, yeah, like this. Then it has to be 0. Oh, sorry, like, yeah, like this. That means s must be, r could be 0, but s can't, because s, the denominator will be undefined. So the smallest number it could actually be is negative. It's a negative. It's a positive number, or positive or 0, right? Then your range goes from -3, k 3 to 0, k 3. The smallest number will be 0. So because of how r and s, how the definition they give you, it kind of shifts how you want your range to be, shifts what your range could be. So this is like a tricky part. In this case, you don't have to do this, and you'll be lucky enough. You do not need to catch this, and you'll be lucky enough to get the right answer. But SAT might be weird and make you force this. And this is a very common question. It appeared in the Blue Book chapter 4, and then I think December SAT last year, DSAT last year. And yeah, so it's a very common question. And then it appeared again just now when you're doing this. I don't know where you got this from, but something like this appears. So it's quite often they love to use this. This is one of the hardest questions, and they love to use it when there's too many 800s. Yeah, when everything else is easy, then they'll add one of these so that it throws people off. All right.